Welcome all. So in this session we are going to solve another problem which is titled as Subarray Sum Equals K. Let's try to understand the problem statement. So you will be given an integer array, for example nums equals 1 1 1, and you will be also given another integer, let's say k equals 2, and you are supposed to count the number of subarray, the sum of the elements of that subarray equals to the given number k. For example, let me define what is a subarray. Subarray is actually contiguous non-empty sequence of elements within an array. That means this is a subarray, this is a subarray, this is a subarray, this is also subarray, this is also subarray. But this thing and this thing grouped is not a subarray. So it should be contiguous. So like that, if you are going to write down the subarrays, that would be this is a subarray, this is a subarray, this is a subarray, this corresponding to the individual elements. Then when it comes to the grouping, initial two elements and the second element and third element, so these many subarrays and everything together, this is also subarray. So you have to see the number of subarray in which the sum of the elements in subarray gives a result of the given element k. For example, here if I take this subarray, that is giving the sum as 2, and if I take this subarray, that is giving a sum as 2, and you cannot find any other subarray that gives a sum of 2. So if this is the input, the output would be 2 in this case. Let's take another example. If the nums is given as 1 2 3 and k is given as 3, so I can find out this is a subarray where the sum is 1 plus 2, that gives a 3. Then this 3 itself is a subarray, that is a sum which gives 3, and other than that I cannot find any subarray. So here also the output is 2. And how can we do that? So there is a brute force and there is an optimal way. So let's try with the brute force first. The brute force solution is to generate all the subarray, and when the subarray sum is equal to k, count that. So like that we can do it. So let's start by the coding part. So class solution, this is the method Subarray Sum. So what are the given arguments? It's nothing but a list of integers is given which is named as nums. Another integer is given k, and you are supposed to return an integer which is the total number of subarray in which its sum is equal to the given k. So let's start with a counter set to 0. Then for I in range of length of nums, so we are going to generate each and every subarray. If I am going to fix an I here in this particular point, then we can all start j from that particular I. For example, we can start j from here and j can go here. If I is fixed here initially, then j should start from here, then it should go here. Like that it should happen. So in that case, let's fix the current sum. So I can use the same color to write the code. So let me keep that consistency. So current sum, current sum equal to 0. Then for j in range of length of nums. Here the current sum would be in such a fashion, j in range of, okay, one thing I forgot to mention, that this j should iterate from where I stands. So I have to make slight modification here. It should be I up to length of nums. So basically these are two pointers, like moving in an entangled fashion. So current sum plus equals nums of j, and any moment if current sum equals to the given number k, then just count it, and when this is over we just need to return the count. So what is the time complexity here? As you can see, we are iterating here, and inside that iteration another iteration here, because like I fixed here initially, j is also here, then j goes here, then I comes here, then j start from the same point, then j goes here, I goes here, then j, like that, it's going like that. So the time complexity here, it's order of n square, and the space complexity, we are not utilizing any extra list or something, so it is order of 1. Can we make it better? Yes, we can make it a better. So the better solution requires little bit understanding of how we can calculate in a single iteration. I am going to explain that solution, because if you intuitively understand, the better solution is easier to solve. So I am going to tell you. For example, if this is a given list, and what we are going to do, we are going to do a prefix sum. For example, starting from 1, 2, 3, 4, 5, 6, 7. So prefix sum would be an array or list that stores sum up to that elements. So first it will append 1 here, 1 here. In the next element it would append 1 plus 2, 3 here. In the next element it will 1 plus 2 plus 3, it will be 6 here. Like that it appends. As it iterates, it appends the prefix sum. So the logic is that at any point, if the prefix sum becomes equal to k, for example k was equal to 6, so here it encountered a 6, that time you can increase the counter. And another case is that at any moment, like if suppose at this particular point the prefix sum, whatever you have encountered, became n. So in the past, if you have encountered any of the prefix sum as n minus k, for example, suppose you encounter 9 and the k here is other than 6, so n minus k equal to 3. Yes, you have encountered a 3 in the prefix sum list. That means from that point, like from starting from this point to whatever the remaining thing is also a valid subarray where the element sum equal to k. For example, if you have got up to here a sum of n, and in the past you have seen something like n minus k here, that means starting from that point to the current point, this is a valid subarray where the element sum is equal to k. Like that we can find any internal subarray like with using this technique. I hope you understand. So this is why we are keeping track of prefix sum, and we are just inquiring, have you seen anything of n minus k in the past? So storing this thing, we will use a dictionary or a hashing tool, so you will get more understanding when we try to solve this particular problem using like the programming language. For that, let me start by copying the class and method definition. Then we can just go and code that particular thing. So here it is. So I need a counter. Here also I need a counter. Then I need a prefix sum, which is a list that I am going to append later. Then I need a prefix map to keep a track or ask in a later time, have you seen something like n minus k, like that, which is a dictionary. Then I am going to start iterating, like for num in nums, for num in nums, then prefix sum would be updated such that prefix sum plus equal to num. If prefix sum, any point, if prefix sum is equal to k, if that happened, that time also you have to increase the count plus equal to 1. If prefix sum minus k in prefix map, if we have seen something like in prefix map, that means there is a scope of a subarray which elements sum equal to k. So that time also you have to increase the count by count plus equal to prefix map of prefix sum minus k. And one more thing we had to do in the end is that updating the prefix map. So we are going to update the prefix map in such a fashion, prefix map of prefix sum equals prefix map dot get prefix sum comma 0 plus 1. Like that the frequency get added, and this is in a single iteration you will get the answer. At the end you just have to return the count. I hope you understood. So what is the time complexity here? Here we are only iterating once and we got the solution. So the time complexity here is order of n. Space complexity, since we have utilized extra list and extra dictionary to keep the track and all, so space complexity is also order of n. So with that I have explained the brute force and the optimal way of solution. So that's how we are going to solve the problem subarray sum equals to k. So thank you for listening. Thank you.